Good morning, sir. Today we'll be presenting about the literature overview of the future of logistics, the space. And I will be passing to the first presenter, Azmira.
Hi sir, my name is Nur Azmira binti Azmi and I will start to explain about the introduction of space logistics. So the term of logistics is the process of organizing and moving resources, people, material, inventory and equipment from one location to storage at the desired destination. The military come up with the term of logistic to describe the movement of equipment and supplies to the troops in the field. The logistic of the aforementioned resources is involved the mixing of production, packaging, warehousing, transportation, security, handling, and knowledge flow. There is an expanding acknowledgement that future space logistics, like the development and sustainment of a lunar outspot. I will pass to the next presenter.
Hi, Assalamualaikum. My name is Muhammad Hakimi. So I'm going to talk about a new strategy for developing of space logistics. So first point is changes in the space logistics trend are very dynamic in innovation living, technology, robotics, which influence the development of a business standard of society. So it inspire all the logistic companies in the logistics space industry because of the benchmark of innovation strategy. So second point is triggered plenty of successful collaboration with customers and partners, which in deriving innovation logistics solution all around the world. So third point is satellite technology is a significant leap in advanced technology. So the changes of space technology system in the future have become more advanced if to compare to the last 50 years. So more spot beams allow for much higher throughput and lower costs and are using frequencies even more efficiently in of intelligent supply chains. Lastly is space companies have been working on to improve the efficiency of automobile by adding the navigation system GPS, which GPS in logistic cars. It used to calculate the road from point A to point B. Uh, this modern technology is this modern technology in space industry will be used by a local intelligence to monitor the consumer product. Thank you.
Alright, Assalamualaikum sir. My name is Noshafika Mutazah. Today I want to present about my article is architecting rapid growth in space logistic capabilities. According to this article, they want to in training in the future's American activities, and the second point is about they assume in the future that in the next 100 years, human will no longer will be stay on the earth because the condition that cannot support for human life, and they talk about where the human will be live after this. So they assume that maybe we can live to the moons, to the Mars, or the place that human can build the spacecraft. And the third one, why they are creating space logistic futures, because it's necessary step towards becoming a true spacefaring nation. And the last one, definition of space logistics can be taken from the following generally accepted definition of military logistics. All right, that's all. I will pass to Nadira.
Hi, Assalamualaikum sir. My name is Wan Nadira binti Marizali. So according to the article Integrated Space Logistic Mission Planning and Spacecraft Design with Mixed Intelligent Non-Linear Programming written by Hao Chen and Koki Ho, They introduced the methods for modeling space logistics, spacecraft, and ISRU. The space logistic model is built using higher fidelity spacecraft and ISRU models. A mixed integer nonlinear programming, which is MINP problem, is used to solve the campaign level space logistic problem using nonlinear spacecraft and the ISRU model. The piecewise function approximation method is described in this section, which linearizes nonlinear ISRU and spacecraft models before converting them to binary mixed integer programming formulations. The difference between the two methods is how the nonlinear spacecraft model is handled. The first method converts the entire problem into a MILP formulation, which should allow it to be solved faster. The performance of the space logistic optimization framework for mission planning and spacecraft design is evaluated and analyzed. ISRU and spacecraft design models are both considered as a baseline solution. They perform an optimization for a single space mission in this section. Then, to investigate the impact of campaign level space logistic design, they optimize a campaign with multiple space mission and compare the result to the baseline solution. The MILP based method is used to complete all of the space mission optimization. The performance of the MILP based method is then compared to that SA based method. Lastly, they run ISRU productivity and spacecraft design sensitivity analysis. Thank you. Next presenter, please.
So SpaceNet use. The SpaceNet was proposed to analyze the lunar spot from logistic perspective. SpaceNet objective is to provide mission planner, logistician, and system engineers software tools that focus on what cargo is needed to support future space mission, when it's needed, and how propulsive engines can carry the cargo. Modeling space mission as a interplanetary supply chains allow user to identify, quantify, and assess the key driver and logistics strategies that influence their physical feasibility and performance efficiency. The goals of SpaceNet strategy is enable user to model and analyze an exploration mission as an interplanetary supply chains in order to address key logistic issues. I pass to Divya.
Okay, so now next slide, please. Okay, my part is about the space logistics modeling framework and SpaceNet tool. So the overview and modeling framework that is written in this article is about the SpaceNet that uses space logistics to construct and evaluate the explorations of the scenario with some of the core components. The network model that is written in this article captures spatial connectivity, which refers to maybe capturing movements of entities or include connection in physical process at varying spatial scales. The resource model captures the substances that are supplied and demanded during the simulation that was being simulated. And for the event model, it catches the actions to guide the simulation execution. So in the key and flexibility features, the multi-level resources model, there are many supply item level in the detailed logistics, while in the less detailed logistics resources, they may be aggregated. In the multi-level demand models, a detailed logistics specifies detailed demand models. The most detailed can be custom coded. And in the mid-level demand, they use linear functions to produce operational elements. And as for the low-level event, all the simulations are defined in a format compatible with a wide range of exploring scenarios. And for the application cases that were written in this article was the first one that investigates the resupply of the International Space Station between the year 2010 and 2015 using 77 missions combining NASA. And the second case model is the Lunar Outpost buildup consisting of 17 flights to achieve continuous human presence. The third one evaluates a conceptual sortie-style mission to somewhat Earth-look-alike objects. And finally, the fourth case is a flexible path-type human exploration in the surrounding of Mars using a combination of human and technology exploration. That is all for me, and thank you, sir.